The legacy of 3I, Atlas, the interstellar visitor that shattered the silence. Long before it ever came near the Sun, the icy traveler known as 3I, Atlas had already seized the attention of astronomers around the world. It was a silent wanderer, adrift through interstellar space for millions of years, a fragment from the birthplaces of distant stars. Only two other objects before it, Oumuamua and Borisov, had ever been confirmed to come from beyond our solar system. But 3I, Atlas was different. It refused to act like an ordinary comet. Hidden within its frozen core were mysteries that defied every expectation. When it reached Perihelion, the point closest to the Sun, scientists braced for a quiet pass, a faint release of gas, perhaps a delicate tail. Instead, the universe delivered something far more dramatic. The visitor erupted in a sudden, brilliant explosion, scattering incandescent fragments in every direction. For a brief moment, it lit up the inner solar system like a burst of cosmic fireworks. This was not a normal breakup. It was abrupt, violent, and entirely without precedent. Astronomers had followed its hyperbolic orbit, a perfect celestial blade slicing through the solar plane, for months. Spectroscopy revealed it was made of materials unknown among local comets. Its surface reflected light unevenly, glittering with metallic shimmer, yet its gas emissions were weak. Models predicted a slow, graceful shedding of dust and vapor. Nothing hinted at what was about to happen. When the detonation occurred, observatories and satellites across Earth and deep space recorded it simultaneously. Within minutes, the nucleus had vanished, replaced by a vast, glowing cloud of debris. The light curve made no sense, far too energetic to be explained by melting ice. Some theorized that exotic ices, such as nitrogen or carbon monoxide, had finally reacted after eons of dormancy. Others believed it was the collapse of a fragile internal structure, worn down by countless cosmic rays. But none of these theories could explain the near-deliberate violence of the event. Spectral data revealed fleeting traces of rare elements, lithium, beryllium, and unidentified emission lines, pointing to an alien chemistry, forged under conditions unknown to our Sun. Curiously, the explosion happened just after perihelion, not during it, as if some threshold had been crossed, as though the heat had crept inward until it triggered a runaway reaction. Ideas ranged from thermal explosions to electrostatic discharges, even the destabilization of metallic hydrogen hidden deep within. The color of the fragments shifted dramatically, from icy blue to deep red. The inner structure of the comet was now exposed, hardened outer layers encasing a fragile, ancient core. Whatever energy had been stored within was finally unleashed in a storm of light and magnetism. High-energy particles surged outward. Solar wind patterns twisted. Even the Sun's magnetic field seemed to ripple in response. 3I, Atlas hadn't merely visited the solar system, it had left a scar of brilliance across it. For astrobiologists, the explosion carried deeper meaning. Could fragments of 3I, Atlas hold organic compounds from another star system? Could they drift for eons through interstellar space, eventually seeding new worlds with the ingredients of life? Each shard became a messenger, a traveler carrying a story from another sun. Some fragments accelerated faster than expected, propelled by asymmetric forces within the debris cloud. It was as if the object had been engineered by nature itself, an intricate choreography between heat, spin, and internal pressure. Even as it disintegrated, 3I, Atlas revealed its hidden architecture, layers of volatile ice, hollow cavities, and stress fractures that had built up over cosmic time. Its destruction transformed it into a natural laboratory, a one-time experiment in interstellar physics, conducted by the universe itself. Polarization readings showed microscopic crystals in the debris, perfectly aligned, relics of magnetic fields from the object's birthplace. Even in ruin, it carried the signature of another world, a fossilized memory of distant stellar nurseries. The legacy continues. 3I, Atlas and the interstellar storm. Some of the fragments from 3I, ATLAS stayed warm far longer than any model could predict. It was as though the debris retained a memory, a lingering heat echo from the explosion itself. Scientists realized that these remnants were made of unusual materials, substances that didn't behave like the ices and dust we know from local comets. Within the expanding cloud, plasma currents began to dance. Charged particles collided, twisted, and spiraled through the magnetic fields, generating bursts of radio waves that rippled across the void. For a few fleeting seconds, the wreckage of 3I, ATLAS turned into a miniature interstellar storm. A storm born of alien chemistry and cosmic electricity. Telescopes detected it as a shimmering pulse, a wave of energy that flickered and faded almost instantly. But in that short moment, humanity witnessed something that could never be recreated on Earth, a natural experiment written in starlight and magnetism. It was as if the universe had opened a small window, allowing us to glimpse the raw, unpredictable mechanics of interstellar matter in motion. The explosion of 3I, ATLAS became a crossroads of discovery, uniting multiple fields of science. Astronomers analyzed its light. Chemists studied its spectrum. Physicists modeled its plasma behavior. And philosophers, quietly watching from the sidelines, wondered what it meant. This single event revealed how alien matter interacts with our sun, how frozen relics forged under foreign suns react when awakened by heat after millions of silent years. It showed that destruction can be more than an ending, it can also be a form of revelation, a transformation where knowledge is born through chaos. Each piece of debris told a different story. Some contained crystalline minerals that formed under unimaginable pressures. Others carried traces of complex organic compounds, molecular fingerprints from an ancient stellar nursery. In studying them, humanity realized that every fragment was both an ending and a beginning, a messenger bridging two star systems across light years of space. As the glowing cloud dispersed, it left behind a trail of dust that shimmered faintly in the solar wind. The particles reflected sunlight for days before fading into invisibility, continuing their slow, silent drift toward the outer reaches of the solar system. And beyond that, into interstellar space once more. In destruction came creation, a cosmic exchange between two worlds that would never meet again. Our sun had touched something older, colder, and infinitely distant. For a moment, two systems had shared matter, energy, and story. That brief flash in the heavens was far more than spectacle. It was a cosmic revelation, a moment that reminded us how little we truly know about the wanderers that move between the stars. How many such travelers have passed unseen? How many have already delivered fragments of alien chemistry to our worlds, seeding the beginnings of life? 3I, ATLAS proved a profound truth, that even the smallest visitor from the void can hold the grandest secrets. It reminded humanity that the universe is alive with motion and memory, that every piece of drifting ice or dust might carry within it the blueprint of an ancient star. Even in death, this icy traveler became a teacher. Through its explosion, it revealed the interplay of energy, structure, and chemistry, a demonstration of physics written not in equations but in light. Now, its fragments continue their endless journey through the galaxy. Each grain of dust still carries the signature of two stars, one from the world it came from, and one from the star that awakened it. They drift through the darkness, glowing faintly under cosmic rays, relics of a story only the universe could tell. Perhaps, millions of years from now, one of those fragments will fall upon another world, melting in an alien atmosphere, releasing the final whisper of what once was 3I, Atlas. In that way, its story never truly ends. The traveler that perished near our sun will live on across time, in data, in memory, and in the molecules it left behind. It came as a wanderer. It left as a message. A message written not in words, but in light, heat, and dust. A reminder that every spark in the cosmos, no matter how brief, has the power to illuminate